Good morning, all of you. So, we have reached our day 4 sessions on our FDP Mathematical Foundations for Machine Learning. Today, in our first session, the topic of discussion and presentation is Mathematical Model for Machine Learning. And the resource person for this session is, sorry, there is a change, sorry. Our topic of today's second session is applications of artificial neural networks in machine learning. And our resource person is Dr. Menaka D. About our resource person, Dr. Menaka D is currently working as Associate Professor in the Department of Electronics and Instrumentation Engineering at Nurul Islam Center for Higher Education, Kumarkoil, Tamil Nadu. She has about 15 years of teaching experience in engineering colleges. About her academics, she obtained BE degree in Electronics and Instrumentation from MS University and ME in Applied Electronics from Anna University. She received PhD in Electronics and Instrumentation Engineering from Nurul Islam Center for Higher Education for the thesis entitled A Novel Method for Land Cover Classification of Multispectral Satellite Images. Her area of interest includes digital image processing, optimization techniques, soft computing, artificial intelligence, and industrial automation. We are very much happy to have Dr. Menaka D as our resource person today. On behalf of Sri Buddha College of Engineering, I welcome Dr. Menaka D to handle the session. Welcome you, madam.
Okay, thank you, ma'am. Thank you for your introduction. And shall I start the share the screen, ma'am? Okay, uh, let's start the session.
Okay, ma'am. Can you put the PPT in slideshow?
Hello. Hello, ma'am.
Hello, ma'am.
Is it audible, ma'am? Can you view my screen?
Voice is breaking, ma'am.
Hello. Is it
Hello.
okay? But
Okay, okay, ma'am.
whether my screen is visible? Okay.
Yes, ma'am.
Yes. Okay. Okay.
Ma'am, can you please put the PPT in slideshow mode? Then it will
Ah.
be
Okay. Okay. Okay.
okay, okay.
Hello. Good morning, all. Hello. Today's session is applications of artificial neural networks in machine learning. Okay, so you have all familiar with neural networks. It will be a mimic of human brain. It will be on working of it will imitate the working of human brain that you everyone know. That then comes the artificial neural network. So today we'll learn about artificial neural network and its applications in deep learning or like machine learning. Okay, so I'll give the overall presentation of the this outline. This is what's meant by neural network. What is then we can compare with artificial neural networks, its applications and some implementation, and we can go little mathematical numerical implementation in Google Colab in the second session. Okay. So this is the overall overview. First, we'll come out with overview of artificial neural networks and its applications. So before that, we have to learn little about the structure of biological neuron. That is, so this is the structure, as everyone know. So it imitates
Ma'am,
the hello. Uh,
hello. Ma'am, the
ma'am.
slide is not changing and the slide is not. Uh, Now only the slide changes and the slide is not in slideshow mode, ma'am.
Okay.
So we can see the screen as a small.
Okay. Is it okay, ma'am, now? Hello.
Hello.
Is it visible now? Hello. Hello, ma'am.
Yes.
Okay. Shall I continue, ma'am? Hello.
Ma'am, can you please close it and open it again?
Okay, we'll check it. Some
Okay,
problem.
okay,
It's
okay,
not.
okay, okay,
Now
okay,
it's
ma'am.
the slide visible. Okay.
Not ma'am. No, ma'am.
No. So in my meet, it's the PPT's presentation is visible, ma'am.
Ma'am, we
Hello.
can see the presentation, but the PPT is not in slideshow mode. If it is in slideshow mode, we can see that PPT in the entire screen.
Okay, here I have closed. I have closed the
Oh,
normal mode
okay,
only.
okay, okay, ma'am.
Okay. Okay. Okay, let's continue. Okay, you know that the term neural means it comes it's the origin, it has the origin from human nervous system. Okay, and we know that its unit of our neural cell is nerve cell is neuron. Okay, so it's present in the brain, and we know that then comes the neural network. So it's a group of algorithms. It's a group of algorithms that define a data set of data similar to the human brain. Okay, so it represents similarity with the artificial neural network. Okay, so the same function of this dendrites, soma, axon, everything is compared with the artificial neural network. Okay, so this connection, that is, you have the axon, then synapse, the interconnections between the dendrites and axons are again compared with the artificial neural network. Okay. Okay, so next slide is the artificial neuron. Okay, so you can see the similarity. You can see the similarity. This is the axon. Then the synapse. That is, synapse means interconnection between these axons and dendrites. Okay, so the whole structure of an this structure of a neuron is imitated with the artificial neural network. Okay, so it has three you have, you know that it will have three layers. That is, it should have minimum three layers. That is, input layer, hidden layer, and output layer. Okay, input layer, hidden layer, and output layer. So that's compared with the artificial neuron. Okay, so there is axon. From the axon only will give an input, and you can check the output based on the weight adjustment and the bias. Okay, so bias is a threshold, will give a threshold value, and you can adjust the weight according to the inputs. So based on the inputs and threshold value, we will be getting an output. Okay, so everything is compared with the biological neuron. Okay, so you can also see this figure which shows an resemblance to the human brain. That is, so from this only it develops the artificial intelligence. So it to reach the solution based on the facts of what is to be attained. That is, by a prediction. So by a prediction, what is to be attained and what resembles the thinking of human brain, if develops the artificial intelligence. Okay, so the backbone of this artificial intelligence is nothing but neural network only. Okay, so neural network emerges later on with artificial intelligence. Okay. So here we can see the inputs, weight adjustments, and bias is the threshold. And we'll give an activation function here for activation function in the sense an input to form the next layer. To there is an input obtained and it is given to the next layer. That is activation function. Based on the activation function, we'll be getting the output. Okay, so that structure is shown here, and the activation function is based on the function, mathematical function like this. Okay, ma'am, I'll have to check out that is whether the screen is moving, ma'am. Hello.
Hello.
Whether the
Uh,
screen is
uh,
moving.
Ma'am, it is not in the slide mode.
Okay, it's okay. I will check Bazaar once again. Okay, but in my PPT is it's showing slideshow only. Actually, now it's in normal mode, and I am closing the normal view.
Okay, okay.
Okay, sir. Okay, sir. Hello.
No,
Hello, sir.
no, no,
No.
no.
Ma'am,
Okay.
ma'am, can you please close that PPT and
Uh,
then again open it?
okay, okay, ma'am. I'll try like that.
Okay. Okay. Maybe some settings has changed.
Sorry, ma'am. Wait for 5 minutes.
Ma'am, it's
So
okay.
I have okay, I have
It's okay.
changed it to
Continue.
slides mode. Okay.
Okay, okay, ma'am. Continue.
Okay. Ah,
Okay, okay. Thank you, miss.
okay. Okay, now I will continue. So, artificial neural networks consist of this neurons are the main body is structure is neurons or perceptrons. Then activation functions. We have to analyze its cause function. Then back propagation, gradient descent. These are the what particular topics which that includes in an artificial neural networks. Okay, so you can able to get the idea of perceptron. So perceptron means nothing but it is a learning algorithm. Perceptron is a learning algorithm used for binary classification task. Okay, so it can be used for classification task. It's based on the uh, what it can be applied to this classification task which makes its predictions. Okay, so it will have a predictor function. So the f of x like that, so it will have a predictor function, and based on the this linear predictor function, and this learning algorithm will assign what it will classify. So for that, for easy going task, the perceptrons are included here, and it will be working based on the set of weights with the weights adjusted to this perceptrons. Okay, so perceptron is an algorithm used for this classifications. Yeah, mainly it's considered for supervised learning algorithms. Okay, it's a learning algorithms, and it's based on predictions, and it works on the predictor function. It will be depending on the predictor function with a set of weights, with a set of adjusted weights. Okay. So here you can see the multiple perceptron networks. So the learning algorithm with multiple layers. So you'll have a multiple hidden layers. Okay, so for high complex networks, so for advanced networks, you'll have a multiple hidden layers. So like convolution neural network, and for advanced types of neural networks, this multiple perceptron is included. Okay, so we can see the difference between this human intelligence and artificial intelligence. So you know that these emotions and some characters, everything will be we can analyze in human intelligence. The same thing is also simulated using artificial neural network. So it is again the same thing happening in the human brain. Okay, so it will capture and preserve the human expertise. What humans are doing, the same thing it will here also the artificial neural network will be capturing. Okay, so it will go for a fast response with ability to handle large amount of data quickly. Okay, so for multiple class task, multiple classification task or regressions, everything for numerical mathematical functions, everything, this ANN will be computing fast. Okay, so that's the main by artificial intelligence. So this ANN is only doing the main task of this artificial intelligence. Okay, then the activation functions, then about the activation functions of this ANN. Okay, so there are different activation functions. um, so its activation function, the role of activation function is to is to decide a particular output. Okay, it activates the neuron. Okay, it So it decides what is to be fired, what is to be applied to the next neuron. Okay, so what input is to be fired to the next neuron. So that is a function of activation function. Okay, so it is added to the ANN. So in order to give the complex patterns simply in a simplified manner. Okay, so the main function is it will decide what is the next input or weight to be fired and or to be given to the next neuron. Okay, so here I can see these are the some types of activation functions like step function, sigmoid, parabolic, sorry, hyperbolic, then linear relief type of activation functions. This relief function is mainly used in CNN type of algorithms. Okay. So these are all mathematical functions, and from the graphical diagram itself, you can understand that. Okay, so it will give a step input. That is either to be 0 or 1. Here it will be a sigmoid function. It's given exponential form like 1 by 1 plus a power minus x. Okay. Then hyperbolic tangent function. These are the numerical formulas used in this hyperbolic tangent functions. Okay, then relief. Okay, then the next one is the cost function. So here the variables like a and y gives predicted values and actual values. And if we are applying the cost function, there is one uh, drawback that it slow downs the training data. Okay, that is it slow downs the learning of neural network. Okay, training of neural network. So another one function is also included, that is cross entropy. Okay, so the main function of this cost function, the main thing is it calculates the difference between actual and predicted values, and it calculates the error. Okay, error. So it calculates the error, and its formula is like this. Okay. So for reducing the error or cost function, so cost function is nothing but error coming in the ANN, and for reducing this error, you can go for cross entropy. Okay, so it increases the learning of neural network. It increases the learning of neural network. Okay, so next one is optimization. So for optimizing the values, learning values, and for finding the for optimizing the for finding the best output, and for producing the error, for reducing the error. So reducing the error means you have to minimize the cost function. You have to minimize the cost function. So if we have to minimize the cost function, you can increase the uh, gradient descent. Okay, so gradient descent is an optimization algorithm or numerical value which is included in the ANN for finding the optimization output, provided you have to minimize the cost function. Okay, you have to minimize the cost function. So if cost function is minimized, your learning output will be increased. Your grade you have your learning output algorithm gives the best output with increased gradient descent. Okay, so this is one of the algorithm. It's the basic algorithm used before the feed forward networks. Okay, so using this here, weights are changed, and we'll get the least cost function or error. Okay, So in an image processing is a model. In an image processing model, there are some thing to be analyzed, some points to be analyzed before the data preparation. So I have to check out the image size, and then a number of images, type of the images, everything. Okay, so then aspect ratio, image scaling, then the standard deviation, mean or average, the normalization, everything you have to analyze before you are going for the there is image processing package. Okay, so one by one we'll see. So what is the image size? So you know that high quality image will give the it will provide more information. Okay, high quality.
Ma'am, Menaga ma'am, participants please stay back.
Hello, ma'am. Hello. Hello.
Hello. Hello.
Sir, sir, now the screen is, sir.
It is not in a full screen mode, madam. Anyway, you present it. We can solve in the next session.
Okay. So, but I have changed it to slideshow mode only. Okay.
Oh, you change it
Oh,
to slideshow. I don't know what
okay.
happens.
Okay. Shall I continue, sir? No.
You just continue, madam.
Okay, now we'll continue. Sorry for the delay, everyone. Okay, so as I already said, the neural network will be composed of comprised of four components like inputs, weights, then bias and threshold. Okay, so inputs, weights, bias or threshold, and outputs. Actually, bias is otherwise called as threshold. In the previous diagram itself, we have studied about that. We have learned about what is meant by what is a bias or what is threshold. Okay, so the four main components of this neural network are ANN or inputs, weights, bias or threshold. Okay, sorry, bias or threshold and an outputs. So this is obtained based on the linear regression formula that is given like this. Summation I is equal to 1 to m wi xi plus bias, that is you have to apply the threshold, it will be equal to w1 x1 plus w2 x2 plus w3 x3 plus bias. Okay, so some recent applications of ANN in this artificial intelligence involves this voice recognition and then pattern recognition, then this natural NLP, okay, language processing, natural language processing, then image recognition, robotics, everything. Okay, so everything comes under artificial intelligence. These are all based upon the working of this neural network only. Okay, that is based on the adjustments of this weight, bias, and inputs. Okay, input layers. So we'll see a simple regression example. See a simple example. So you have to you are going for an uh, uh, dinner and for ordering a pizza for the dinner. Okay, so you have to, this will be our predicted output, that is whether you have to you like that is it's an example like that you should or what you should be ordering. Okay, whether you are going to order a pizza or not. Okay, whether you are going to order a pizza or not, that is an example, just an example. So your predicted output will be y hat. Okay, let's assume that there will be three see, three factors. It's based on the three factors, and if you will be saving the time by ordering out, it is whether it will be okay means it is yes, or yes means one, and no means zero. Then if we ordering a pizza, you will be losing your weight. Okay, that's one thing. Then you will be saving your money. Okay, if you are not ordering. Okay, like that you are taking three factors. Okay, so if it is okay, yes means one. If it is no means zero. Okay, so based on the following inputs, that is first one is you are taking three input factors x1, x2, and x3. Okay, so first one it's coming as just an example. Okay, just an example. First one is high, and you are not making dinner. If it is the second one is zero, x2 is zero, you are not getting all the because of some reasons. Okay, it's not good like that. Because you are not getting all the toppings or the pizza, you are not ordering. Okay, so x2 is 0, and third one is x3 is 1. You will be saving the money. So uh, for that you are not ordering, so your reason is only you will getting two slices like that. Okay, uh, so based on these inputs you have to assign some weights. Okay, you are giving the giving for the predictions, you are assigning some weights. Okay, so um, that is first, since you value the time, you are giving importance, you are giving preference to time. Okay, you are giving importance to time, so that you are taking the w1 weight as 5 points. Then w2 is the value was 3, and w3 is 2. Okay, that is you the second point is it's given it's you're taking the shape as a value. You value only this shape, you're giving 3 marks. Okay, then third one is third weight is you're giving 2 points for your since you have got money in the bank. Okay, like that you are giving preference to money. Okay, so you're giving value to time, it's 5. You're giving to you are valuing your you are valuing the shape of this pizza, that is you are giving the 2 marks. You are giving you are considering the money they are giving 2. Okay, so this is considered as a weight. Okay, mm. Then you are at giving a threshold value or bias value. Bias means at a reference, so a limit. Okay, limit that should be 5, and if the threshold value was 5, its bias is to be -5. Okay, now using the activation function, you know that activation function, it takes the output to the next layer. It takes the output to the next layer. That's the function of the activation layer. And for the activation, you're getting the activation output by using this formula. And mm, finally you're substituting everything, and you're getting the output. Okay, your predictor output is you are deciding to order uh, whether you are deciding or not. Okay, so the final output is 2, which is greater than 0. Okay, so which is greater than 0. So that is the thing is that what from it is compared with the activation function. Okay, just if y hat is 2, which will be greater than 0. So if it is greater than 0, what is the thing, the function will be activation function is f of x is 1. Okay, the activation function here you can see that 1. Okay. Mm. Hello, excuse me, sir. Hello.
Okay, ma'am, please continue.
Yes,
Please
yes,
continue.
ma'am.
Okay. Okay. Okay, we're checking the output, predicted output. Our predicted output is compared with the activation function. Okay, our predicted output is compared with the activation function. So our predicted output will be you are getting is 2. That is, it is compared with the activation function whether if it is greater than 0 or not. Okay, so here it's found that it is greater than 0, and therefore the thing is that high value. Okay, so the activation function will be 1. So it means that means that they are ordering the pizza. Okay. So like that you are obtaining the uh, predicted output. Okay, you can get the predicted output here. So this predicted output is based on the threshold value. Okay, based on the specified threshold value. And if that node is, if the threshold value node is activated, it sends the data to the next layer of the output. Okay, so for that only we are using the activation function. Okay, so activation functions are different types of activation function according to the requirement of the feedback or feed forward layers, according to the hidden layers. Okay, according to the requirement of our application, we are selecting the hidden layers. um, uh, and based on the hidden layers we can use either sigmoid function or hyperbolic function or any type of RLU function. Any type of activation function is used based on the number of hidden layers. Okay, based on the complexity of the network. So if we can imagine that you are giving different inputs. See, here you have here you have assumed three inputs as valuing the time, valuing the money, and mm, you are giving preference to shape, like that. You are assuming three inputs and you are changing the input now. So you are giving some training to the data, and you are changing the inputs, and if it is repeated multiple times for a single decision, for a single predicted output, this neural network is to be may have to be extended with multiple hidden layers. Okay, so if this process is to be repeated multiple times, and you have to get obtain different outputs. So what is the need here? Have to use multiple hidden layers. Okay, you have to use multiple hidden layers. Now comes the deep learning algorithm. So then now this neural network will be uh, changed to multiple hidden layers with multiple perceptrons. Okay, so that leads to a deep learning algorithm. So deep learning algorithm will have more than 3 layers. So actually the minimum layers of a neural network will be one input layer, one hidden layer, and one output layer. Okay, one input layer, one hidden layer, and one output layer, and totally there will be 3 layers in an simple neural network. And if it changes to if it is converted to a multiple neural network, you'll be having more hidden layers, and the minimum will be extended more than 3. Okay, so you are calculating outputs from each hidden layer and summed up to calculate the final output of the neural network. Okay, so summation of the individual output of each hidden layer is important to which gives the final output of the neural network. So actually, this neural network will be the backbone of artificial intelligence. And now we'll check out what is the artificial intelligence. Okay, so you know that it requires human intelligence. It requires intelligence which is done by humans, and
Excuse me,
it
madam. Please
Hello?
change the slide. Please change the slide.
Okay. It's not changing, sir.
Yeah, yeah, okay, okay.
Okay. So you can also get the know that AI, which is the study of ideas that enables computers to be intelligent. So it replaces the humans, human work, and which enables computers to be the machines to be intelligent, like or more than to be human. Okay. So it's defined as the science of making computers to be a more intelligent. Okay, now we'll see about the difference between what is machine learning, what is deep learning, and what is neural network. All comes under this artificial intelligence. Okay, so it's a type of artificial intelligence that allows software applications to learn data and become more accurate in predicting outputs. Actually, machine learning is a method or a learning algorithm which predicts output without any human intervention. Okay, without any human intervention, it predicts the output. Okay, so it is a method of artificial intelligence to uh, learn from the previous training. Okay, trained data, and it will have a particular data set. It will have a set of instructions, and with the help of these instructions, the machine will learn, and based on the data, predict will give a predicted output. Okay, the same thing you can also uh, tell here, that is it will also, the machine learning ML will be mimic the way how the brain, how our brain works. Okay, so the computerized ML languages, ML will be based on different languages. So most probably this basically these languages used are this Python language, then NumPy, so spelling mistake, NumPy language, then Pandas. Okay, so it based on the libraries like Jupyter, then Colab, okay, everything, Anaconda library. So based on these libraries, ML languages can be analyzed. Okay, so it is nowadays the same, these Python, the NumPy, everything is nowadays utilized for different applications. So how do this artificial AI, means AI is artificial intelligence, machine learning, neural network, and deep learning relates? Okay, it's shown by different ducks. Okay, artificial intelligence. It's a machine learning. It's a subset of artificial intelligence. Neural network. It is the subset of machine learning. Then deep learning. It is the subset of this neural networks, machine learning, and artificial intelligence. Okay, so you can see the explanation here, that is machine learning, it is a subset or subfield of artificial intelligence. Deep learning comes under machine learning, and neural network makes up the backbone of deep learning algorithm. So for developing a machine learning or deep learning algorithm, we need to design a neural network, ANN, artificial neural network, based on the predicted this weights and threshold values. Okay, so the depth of hidden layers, it only distinguish a single neural network from a deep learning neural network. So deep learning means multiple neural networks. Okay, so the other word of this multiple perceptron neural network, or multiple um, neural network, artificial neural network is nothing but deep learning. Okay, deep learning differs from a single neural network by counting the number of hidden layers. So more number of hidden layers, the system is to be complex. So the minimum number should be more than 3. Okay, for a deep learning network, the layers must be more than 3. Okay, a single neural network will have a single input layer, minimally it will have a single input layer, single hidden layer, and a single output layer. So comparing with that, the deep learning will have more data, more uh, networks than this uh, single neural network. So this shows the this figure shows the relation between uh, complex this multiple neural networks or deep neural networks. Okay, so the deep neural network will have more number of hidden layers. Okay, more number of hidden layers with one input layer and one output layer. So here you already know that these are the input layers. We can label it as x1, x2 up to xn, and here this will be the based on the activation functions. Based on the activation function, the weights are applied to the next layer. Okay. Then the output of this first hidden layer is given to the next hidden layer. Okay. Like that it goes on. So next slide is how the deep learning network is different from neural networks. How deep learning, how you can say, can you say? Okay, it's simple. So it's neural networks will be based on the number of layers. Okay, number of layers. So the deep learning algorithm will be uh, consist of more than 3 layers, which should be inclusive of inputs and outputs. Okay. So that is the difference between a single neural network and a deep learning network.
Hello, ma'am. Hello.
Hello?
Hello.
Hello, sir.
Ah, ma'am, your voice is breaking.
Voice is breaking. Hello.
Yeah. Right now, no problem. Okay. Okay. Please continue.
Okay. 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 So as we know the we are learning about the deep learning networks, we have to identify the difference. That is, computer is a machine, and you are solving this network in the machines, and you have to identify the difference between um, this what computers and this neurons, everything. Okay. So you can see the difference between uh, this neuron size here. It's compared with the transistor size. It's compared with the transistor size. Then energy consumption, uh, everything is more than that of this nerve cells. Okay. So taking the work of this brain, human brain, okay. Your function is more utilized in deep learning networks. Okay, that is comparing with the human brain. The the functions are imitated, and the output, the response is more than that of the biological neurons. Okay. So neuron cells, the learning capability is compared with the programming capability. Here are programming the machines. So in this slide, you can see the difference between ANN and biological neural networks. The difference between ANN and biological neural networks based on the some different parameters like speed, processing. Okay, processing, then size and complexity, storage of the data, then error. Okay, error or fault tolerance method, fault tolerance. Okay. So in all the thing, here you can check that you will be checking that the output will be fast in response compared to the biological or real neural network. Okay, so the speed, faster in processing, response time is nanoseconds, and here in neural network, it is the processing information is slow. Okay, the processing information is slow with uh, response time is more compared to this artificial ANN. Okay, so here it is in nanoseconds. In biological neural networks, it is in milliseconds. Okay, then serial processing method is adopted here in our ANN, and massively parallel processing. Parallel processing means at a time you can do multiple tasks. Okay, so using the main advantage of parallel processing is you can do multiple tasks comparing with the serial processing. Okay, serial processing means cascade arrangement. That is one by one. First you'll get the output, and then that is to check, that is compared with the next input, like that. Okay, like next input, and that this output, second stage output is again given to the third stage. Like that, it is going on, and in parallel processing, simultaneously more number of tasks is done. Okay. Then based on size and complexity, it's the size is less, and complexity is reduced. Complexity is reduced. So there the what the pattern recognition task is not complex here in ANN. Okay, so comparing to this biological neural network, it will have a dense network. It will have a high complexity. It will have a dense network. It is uh, okay, densely, that is compactly connected. The neurons are compactly connected. Okay, so interconnected with dense arrangement. Okay. Uh, in the order of 1011 to 1015 of interconnection, that is, its complexity is very high. Complexity is very high. And in ANN, it will have less complexity, and less size. So what is fault tolerance? Fault tolerance means error handling. Okay, error handling. Computer people will have an idea about fault tolerance. Okay, so here corrupted information is one disadvantage, that is corrupted information cannot be retrieved in case of failure of the system. Okay, in biological neural network, the information stored is can be adjusted. Okay, uh, with the new information. It can be adjusted with new added information, with what, with a more number of interconnections, more number of hidden layers, without destroying the old information, okay. So next one is similarity and difference. From this table itself, you can get clear that neural network acquires knowledge through learning method or training data. Uh, it is also similar to the biological neurons. Okay, then it's based on interconnections with the weight adjustments. So the weight adjustment is also there, found in biological neural network, which is also known as synapse or synaptic weights. Okay, these are the similarities. So the comparative diagrams with threshold is here. This is the activation function applied here. Okay. So comparison. Okay, I have got a message that slide is not changing as a. Hello, sir. Is it okay? Slide visibility. Is it is the whether the slide is changing, sir? Anil sir.
Slide is not in the slide mode. Anyway, you just continue. Okay.
Okay, the same problem is continuing.
Yeah, yeah.
Sorry, sorry, sir.
After the break time,
After
we rectify
okay,
it. Okay.
okay. Okay, how does artificial neural networks works? That is based on the threshold limit and or bias applied to the activation. This is here the summation. This summation is activation function. Okay, here this activation function is based on the weights applied here. Weights applied to each input layer. So here this is multiple inputs are given here, and here the bias value is 1. Okay, the bias value is taken as 1. It is based on this threshold. Okay, it is based on the applied threshold. So here b is represented as bias, then w1 to wn, that is weight adjustments, and x1 to xn is our inputs. Okay, so based on this inputs, I have given a formula in the previous slides. You can check it. So in that numerical formula, this activation function is included, and you can get the output of a single neural network. Okay, similarly each layer, each neural network is calculated, and the output is summed up for a multiple perceptron layers. Okay. So you can check out this diagram with this explanation. So each input is given with each weight adjustment. This artificial neural network will receive the information from the that is inputs from the external from externally. It will be getting the output, and it is designated as xn for n number of inputs, x of n for n number of inputs. So x1 up to xn. Okay. So this ANN, single neural network of ANN can be viewed as a weighted directed graphs. Okay, it is always that as the weighted directed graphs, in which weights are adjusted, weights are interconnected between this neuron outputs and neuron inputs. Okay, so each input is multiplied, each input is multiplied with its corresponding weights. So x1 w1, x2 w2, x3 w3, similarly xn wn. Okay, so each input is multiplied by its corresponding weights, and weights are nothing but the information used by the neural network to solve that particular problem. Okay, weight represents the strength of the interconnection between neurons inside the neural networks. So weight is nothing but the strength. It will give some boost up to the inputs. Okay, so the weighted inputs is nothing but inputs multiplied with the weights. Okay, weighted inputs are the inputs multiplied with the weights. Okay, so that again summed up, each input multiplied with each weight. So x1 w1 plus x2 w2, so summed up, and inside the computing unit of the artificial neural network. So if in this case, for example, in this case, if the weighted sum is 0, the bias is added to the output. uh, and bias will have the weight and input which is always equal to 1. Okay, bias is normally 1, and and the summed up final expression or the numerical value will be ranging from initially 0 to infinity. Okay, and to give or to limit the response to arrive at a desired value, or to getting them for stopping the training, a threshold value is given. So okay, threshold, the function of threshold value is to limit the response which is to be arrived at the desired value. So for that, the threshold value is given. And what uh, this activation function, the activation function is based worked upon the threshold value. In the previous slide itself, I have given the numerical formula for activation function, and it is based on either linear and or non-linear, and just it will obtain the desired output. Okay, now we'll go for we have analyzed about what is artificial intelligence, what is machine learning, and what is deep learning. What is deep learning is means it's a so it will be coming under the subfield of machine learning and artificial intelligence. Okay, so deep learning, you know that it is developed by multiple neural network layers. Deep learning network is developed by with the help of multiple neural network layers, which will be occupying with which will be compromised with more than three layers. Okay, single neural network will be having one input layer, one hidden layer, and one output layer. Okay, its function, it will give a separate output based on the inputs and threshold, and it set with setting a bias value of 1. Okay, That is what neural network, and multiple neural network will be the basic of this deep learning network. Okay. So deep learning is a technique which performs machine learning inspired by human brains. Okay, that is nothing but a neural network only. Okay, neural network. Then machine learning, it is a technique by which computer can learn from data without human intervention. Okay, uh, without using complex set of different rules. Okay, so by means of training a model, you from data sets, by using training the data from different data sets, machine learning can be obtained. Okay, so then mimicking the intelligence of a human behavior, and uh, by undergoing this machine learning, deep learning, you will get the artificial intelligence. Okay, so in artificial, under the artificial intelligence, uh, will be what mm, setting of machine learning algorithms as well as deep learning algorithms. Okay. Okay, you understand that the basic of this is neural network. If you design a neural network with multiple hidden layers and multiple inputs and outputs, everything, you will get a deep learning network. When you are learning this deep learning by giving a computerized way, in a computerized way, by some learning algorithms like this Python, uh, uh, pandas, everything. Okay, numpy algorithm, using this computerized learning algorithm, if we learn this deep learning network, it is to be called as machine learning. Okay, so overall thing of this machine learning as well as deep learning, saying as artificial intelligence. Okay, now this artificial intelligence is interlinked with the industrial 5 4.0, then industry 5.0, then automation, robotics, everything is interlinked with this artificial intelligence. So you are, don't confuse the artificial, under the artificial intelligence, you are going through this machine learning algorithm. Okay, so under this machine learning algorithm, you are coming up with deep learning networks. Okay, this is the overall way of, or the flow of this deep learning networks, computerized learning algorithms. Okay, so this is the graphical representation of uh, combination of deep learning, machine learning, and artificial intelligence. Okay, so deep learning, it is specified, represented by this human brain networks. Okay, networks of human brain. Machine learning means you are getting an idea. Okay, you are getting an idea that is given here, that is shown here. With the help of this computerized software languages, you are developing machine learning algorithms. Okay, this neural network is computerized using software algorithms, and both will be, we are saying, as artificial intelligence. Okay, okay, so the same thing, the again the same deep learning and machine learning are compared with this pictorial view. Okay, so you can see the deep learning network. You are giving an input, uh, whether it is a car or not a car. Okay, whether this car is to be identified, predicted. Okay, it should be predicted as car or it is not a car. Okay, you are giving some different inputs. What are the inputs here? It's nothing but features. Okay, it's the shape of the car, its color, the what it's what uh, based on the structure. Okay, means pattern. We can give the texture pattern. So two wheeler or something else vehicle will be different. The structure will be different than the car, isn't it? You can give that input, one that structure or texture or pattern as the input here. So we'll call that as the features. Okay, so some features are extracted from this input, that is car. Okay, so that is labeled data. So you can give that labeled data set in a supervised learning algorithm. Actually, from the feature slide it will be coming up. That is deep learning. You'll have different types of learning algorithms, okay, under the deep learning. So you'll be familiar with the supervised learning algorithm, then unsupervised reinforcement learning algorithm, then something like offline learning, online learning, like that. It's there in deep learning algorithms. Okay, supervised, main algorithm used are supervised and unsupervised learning. Okay, if you are giving a labeled data set, or if you are training the data inputs, if you are training the inputs, it's said to be it's meant by what supervised, supervised. Or if it is if you are not training the input, so if you are not training the input, that is said to be unsupervised, and the mixture of both will be reinforcement. Okay, like that. So different learning algorithm, based on the learning algorithms, the output is classified, and you'll get the output as whether it is car or whether it is not a car. So based on the classifier outputs, you'll be giving, you'll be getting the response. Okay, so in machine learning, you are machine based feature abstractions. So this is the difference. So from the diagram itself you can understand. So some softwares are used here, some softwares are used here, or some machine based algorithms are adopted for taking the features, and then it is given to a network. Okay, then it is given to a neural network. So these change is only adopted uh, when comparing to this deep learning. Okay, so that is both are same, almost same, but here you are computerizing the features. You are giving the inputs to a machine, and based on some software algorithms you are getting the response classified output as either car or not a car. Okay, understand? So participants, if you have any doubt, you can ask me.
Participants, any questions, please ask. Dear participants.
Ma'am, your session was very good. So I request you, please, if you can share the
Okay.
this recording, also this PPTs, and one
Okay, sure,
question
sir.
I want to ask you, that how we design this function, the summation function, or uh,
Yes, sir, I already discussed that. It's based only on the activation function. Okay, so
yeah,
that is you are
activation
giving
function.
the activation function. There are different types of activation function based on the application. There is sigmoidal, like different functions are there. Step input. There is you are giving the. I have taken an example, prediction regression example, no sir. So if you are giving different inputs, you can check it as whether it is yes or no. You can predict. So that trained data is given as the activation function, and that activation function is worked based on the bias given to the activation function, and its output is coming from each input layers, each hidden layers. Okay, then the final output is summed up for all the hidden layers, and you will be getting the final output. So, sir,
So
what's the
I think
break time?
it depends upon the application, the type of activation function we can use,
Ah,
right?
yes, yes, sir. Yes, sir. Right,
So
sir.
let us suppose we have one example of like we want as you have indicated in the last your PPT slide, that input is some vehicle, right? And then
Ah, yes, sir.
feature extraction is given, then classification, then output, whether
Yeah.
so in this particular example, it is a rough example, I understand. So what type of activation function we can use as a uh,
Oh, okay, sir.
whether we
Here in
use
this
sigmoid
given,
function or any other function, because there are many
here
many
you
type
can
of
use
activation
here
functions,
you
so
are taking as
sometimes it
only
becomes very difficult
step
that
input. You can take as yes, sir. You can train the data with the different activation function also. Also, you can train the data with different. First, this this is the basic example. You have to you are getting the output as either yes or no, whether it is car or whether it is no. So you can use a step input function. That is high. If it is high means one, if low means zero. You can use the step input function. Or otherwise, if it's not getting the similar output, you can recheck the output with the different activation functions also. Okay.
okay. So I
Okay, sir.
think this
Okay.
particular example, the stepping function will be
Step input
useful, right?
can be used. Okay.
Thank you, ma'am. Thank you very much.
Okay, sir. Okay,
So
sir.
can you share this recording with us today?
Okay. You can contact the organizers, and I will be
Okay, okay, okay,
forwarding.
sir. Okay, sir.
Okay.
Don't worry. We share all the
Okay.
recorded videos.
Yeah,
Okay,
it was
Okay.
wonderful session, sir. Very nice.
okay. Thank you, sir.
Okay. Thank you, sir. Okay, sir. What is the
Ah,
break time, sir? Okay.
this time is this time. This okay.
Okay.
Uh,
Okay.
at
Will be
right now,
when.
we conclude it in the first
Oh,
session. Uh,
okay.
uh, and the next session start at sharp 11:30.
11:30. Okay. Okay. Thank you very much, sir. Let's have a break and we'll be rejoining at 11:30. Okay.
Okay, madam.
Okay. Okay. ഇനി പി പി ടി ഓപ്പൺ ചെയ്യണോ? ശരി. ആ ഓക്കെ. ശരി ശരി ശരി. ഓ അപ്പൊ ഇപ്പൊ ഇത് ഫുൾ സ്ക്രീൻ ആണോ കാണിക്കുന്നത്? ഓഹോ സോറി സോറി.
Hello, madam, can we start the session now? Hello, Menega madam. Okay, participants, please stay back. She will join soon.
Ma'am, shall we start?
Hello, ma'am. Hello. Hello.
Hello.
Yes,
Yes, madam.
Ma'am, is it okay, ma'am? Slideshow, is it
Uh,
visible?
is it
Full
visible?
screen?
But ma'am, it is not in the full screen.
put in slideshow, ma'am. Okay,
Okay.
ma'am.
Okay. Okay, ma'am. Okay. Now it
Okay.
is okay.
Okay. Okay. Okay, participants, let's continue the session. We have discussed about an example for deep learning and machine learning, isn't it? So I have given a vehicle and we have to predict that whether it is a car or not. Okay, so we can, this shall be compared with either deep learning algorithm and machine learning algorithm. Okay, so in deep learning algorithm, the features are taken directly to the network and the response can be viewed based on the activation function. And here in machine learning, it is computerized and it's based on computerized languages, and then it can be the the input can be classified. Okay, so I'll go fast, and I have an we can implement simple expressions using collab. Okay, like for the last half an hour session. Okay. So now we'll be getting an idea about what is exactly and deep learning, and uh, why it is better. Okay, why it is chosen as better network. Okay, so why because of its different learning features. That is, it have different modes of layers, different layers. Okay, series of layers between this input and output, and in each step their features are again extracted again, and processes are further going on, and I will get be getting an accurate output. Okay, so in this convolution neural network, there is also different layers, different hidden layers, and based on the pooling, and you will be getting the based on relay activation function, you'll be getting the accurate output in a better way. Okay, so that we are preferring deep learning nowadays. Okay, so when you prefer this deep learning in artificial intelligence, it's based on different types of networks. Okay, so there's hidden layers are perceptron layers. Different perceptron layer are based on feed forward layer, then single layers, multi layers, and it's
Madam, you are not audible now.
Okay, sorry for the interruption. Uh, okay, we are discussing about how artificial intelligence comes in sorry, how neural networks, the types of neural networks are involved in artificial intelligence. Okay, so based on the collection parameters, based on the hidden layers, based on the weights, and based on the memory units, the types of layers are utilized. Okay, it may be like this: feed forward. It will have no loops. Okay, it will be in the forwarded mode, that is, it will have no feedback loops. Then a single layer, it will have only one layers, single perceptron layers. And then multi-layer means it will have multiple layers. And fixed and adaptive, fixed weights are fixed. And adaptive means the weights are getting updated, that is based on the training. So it will be used in uh, supervised learning algorithms. Okay, so in supervised learning algorithm, training is needed. So training in such cases, when you are going for further and further training, the weights will be getting updated. Okay, so that type of neural network is adaptive neural network. Okay, in fixed type of neural network, weights are fixed. Once it is fixed based on the priority of the inputs, priority of the features. Okay, based on the features, weights are it will be fixed, and it is not changed for the whole network. Okay, so that's about fixed and adaptive layers. Then comes the static and dynamic layers. Static and dynamic network. So static is memoryless unit. It will not have the memory. And for example, mm, the current output, the output will be depending upon the current input. Thus it's not based on the history. Okay, it's not based on the history, and current output will be based on the current input only. Okay, so feed forward type of network comes under the static type. Okay. Then dynamic is the output depends upon the current input. The output depends upon the current input. So for example, recurrent neural network is one of the type of dynamic neural network. Okay, so the different types of you can see the different types of architectures. Okay, found in neural network. Single layer radial basis network. So based on the kernel, it is classified as radial basis neural network. Okay, then multi-layer perceptron. Recurrent neural network. Recurrent means feed forward type of neural network. Then like that, different neural networks are there. Okay, so radial basis neural network uh, will be used with the radial basis functions. Okay, radial basis functions. Okay, then hope field type of neural network. Then LSTM, recurrent neural network. LSTM means long short term memory. Long short term memory. Okay, it is a feedback type of neural network. Recurrent means yeah. And the LSTM means it is a feedback type of neural network. Long short term memory type of neural network. Okay, it is a type of feedback loop. It's a feedback type of neural network. So these are the representations given. Here it is green is the input, blue is the output. Then this up arrow is feedback with memory unit. Feedback with memory unit. And this red color up arrow means probabilistic. That is randomly chosen hidden unit. Backford hidden unit and hidden unit with okay. Okay, now we'll see the learning techniques. Learning techniques in neural networks. Okay, so learning techniques, these are the different types of learning networks used in the uh, ANN. Okay, ANN or deep learning. Okay, so here these are the 5 types, that is supervised, unsupervised, reinforcement, maximum. These three are one among these three will be used basically. And another one, two is offline and online also. Okay, so supervised means here the training data, here training is done. Okay, here with some labeled data set, for some labeled data set already. So if it is a vehicle, it will be for these type of features, the vehicle should be it's assumed as car. For these set of features, if these set of features are getting, the output will not be a car. Like that, it is predicted already by a training data set. Okay, so if that is already labeled data set, so if that labeled data set is used, that is meant by supervised learning. And if it is not trained, so whatever the features, it is directly given to the network, and the output is obtained, and it is based on adjusting the weight only, weights. Okay, so the feature extraction is trained by the network itself. Okay, that is unsupervised learning algorithm. And this reinforcement means the network provides feedback whether the output is either wrong or no. That is both, it will be learning, or it will be directly saying the output. Okay, so it can be either semi supervised or unsupervised. Sometimes it will be working as supervised, and sometimes it will be working as unsupervised. So it is reinforcement learning. Okay, then the weight adjustment based on threshold made after the labeled data sets, that is after the training, that is known as batch learning or offline learning. Okay, similarly the more type is there. So these are rarely only used. So maximum this supervised unsupervised learning algorithms are adopted in every deep learning algorithms. Okay. So this the pictorial form I already shown. The same type of the same slide is again repeated. That is the different types of architecture, different architecture of neural network for deep learning algorithms. Okay, feed forward type, feedback or recurrent. Feedback or recurrent, then LSTM type, long short-term memory, then Hopefield type, Boltzmann type, self-organizing, convolution type, everything based on the application. One of the type is chosen. So I have to understand the difference between this already previous slide. Okay. So you know that neural network, when it is trained iteratively, repeatedly, when it is trained iteratively or repeatedly, you will be getting a deep learning network. Okay. So some examples I have shown. For first one is pattern recognition. So based on the input features or input patterns, decision can be made. Decision can be made, that is either it is uh, yes or no. That is decision. Okay. So different applications of neural networks in deep learning. Okay. So you can see the slide. Based on the, it will be, it has, you can check that different activation functions are shown here. Based on the activation function, this application can be more varied. Okay. some more applications. So everywhere nowadays, this machine learning is adopted using the algorithms, using software algorithms. Okay. So e-commerce, digital marketing, healthcare, then automation, virtual assistants like chatbots, everything. Then voice recognition, you know that it's Alexa, everything, Google Assistant. That's all voice recognition. Then speech, voice and speech recognition, voice and speech recognition. Then face recognition, pattern recognition, biometrics, in social media. Then financial services, everything in financial services, fraud detection can be checked out using machine learning, like artificial intelligence. Okay, these are all you'll otherwise say as artificial intelligence. Okay, so artificial intelligence is nothing but machine learning. Machine learning is done with the help of deep learning network. All the everything is interlinked, and those who are studying this artificial intelligence, including which involves this deep learning, machine learning, etc., will be will be saying as data scientist. Okay, data scientist is the one who is dealing with artificial intelligence, this machine learning and deep learning algorithms. Okay, so now there's a big job opportunities for data scientists only. Okay, so now artificial intelligence are made uh, a very highly demanded area. Okay, job oriented area, and data scientists are very much offered for doing these programmings or codings, like machine learnings. Okay, machine learning algorithms. This is the overall flow of a machine learning process. So first we are training the data, we are learning the algorithm, then we are building a model. Here only you are programming. You are building, you are designing a model, and you are performing the task. Okay, we are monitoring the task. So this is the flow of, and then after the finally you'll giving a you're checking the output, and again the algorithm is learned. Okay, feedback is used, and we are learning the algorithm. Okay, so you're training the data, you are learning the algorithm, and you're building the model with the help of any type of either supervised or unsupervised, or the algorithm is either supervised or unsupervised. And here the model is whether it is a feed forward or feedback or recurrent or something else. Okay, that type of what type of network is to be chosen. So the output layer is checked, and that output is verified and fed back to the algorithm again. Okay, so that like this the process is getting repeated. So this studied already. Okay. Okay, we'll go first. And different learning algorithms, mm, it is based on these are the applications of supervised learning. Okay. Uh, so supervised is nothing but training the input. Training the, if it's where we have an input variable X and an output variable Y. Okay, the function of input variable is the output. The function of input variable is the output. That is, you are mapping the output from the input. That is, you are learning, you are training the data set here in the supervised learning, and these are the applications. And using some different classifier algorithms. So random forest, KNN, everything, decision tree algorithms are all classifier algorithms. Okay. So linear regression means estimation of real values. Okay, estimation of real values. It is the application where supervised learning algorithm is used. Then logical regression, efficient. These are all different supervised learning algorithms. Okay. So non-labeled data without any label of the features, classification is done. That is defined as unsupervised learning. So accuracy will be better in this unsupervised learning. Okay. Sorry, accuracy will be better in supervised learning compared to the unsupervised. That is, here it will be predicted output. In supervised, training is done. Training is done, and then you will get the output. So these are all examples of classifiers. Okay, K means clustering, hierarchical clustering. Everything comes under unsupervised learning. Third. So this I already said it will be either it works as supervised or otherwise as unsupervised learning. Okay, this is one of the another example or application of artificial intelligence. That is robotic process automation. Nowadays, artificial intelligence exists into robotics also. Okay, so it is the software or programming software that helps the human to make the process in a automatic way. Okay, the control process, it's mainly used in automations. So automations, when it comes in, okay, intelligent machine, it's said as robotic process automation. Okay, so without human intervention, the process can be controlled. So that is about RPA, one of the application of artificial intelligence. Okay. This is the workflow of automation that is it is used to automate workflow. Then back office processes, then infrastructure. All the three comes under robotic process automation. They're all working with the help of adjusting the weights. That is training. So these figures explain the training data. Okay. So you'll have a decision boundary. Over the decision boundary, it will be the output will be whether it is yes or whether it is no, and comes under the border. Okay. There is a response is shown in this graphical structure. Then the last one is wait. Different applications I have given, but it's not that it's not time. Okay, we'll see this. So instead of this vehicle here, an object or animal is shown, whether it is for deep learning. Okay, so one of the application. Then iris flower, classification of iris flower based on different features. That is one of the example. These are all implemented examples. Okay, I'll show. So this is the iris flower data set. Here I have taken 50 samples in each class. So one will be a linearly separable, that is, and different types of flowers are taken. And for 4 inputs. So the data is the inputs are classified for 4 inputs like sepal length, sepal width, then petal length and petal width. Okay, so by taking these 4 features, it's given to the training is done in using classifier, and you are getting the outputs. This is one project done by my scholar. Okay. So from the confusion matrix of the classifier, we can verify, we can check the outputs. Okay, that is one example. Similarly, if you know the coding idea, you can do any type of algorithm. This is handwriting, digital handwriting using deep learning. Okay. And the last topic is I've thought to tell about convolution neural network. Okay. So anyone, do you have an idea about convolution neural network? So it is a type of deep learning algorithm. Okay, it is a type of deep learning algorithm, and it will have different process. So there is a more hidden layers will be there. So here it is. Okay, it will have more hidden layers. I will show the diagram. So this is the architecture of convolutional neural network, and feature extraction. In the part of feature extraction, different layers like pooling layers, different pooling layers, and each pooling is will be done with the help of convolution. Convolution is done with relieve means an activation function. Okay, relieve is an activation function. So these all carried out in convolution neural networks. Okay. So what is the meaning of pooling? It reduces the dimensions of feature maps. Okay, it reduces the number of parameters that is used for computation performed in the network. Okay. So different pooling is often done in each convolution layer. So here for multiple layers are given. We say each layer will be saying as convolution layer, and each pooling layer is a new layer. Pooling layer means it is a new layer which is added after the convolution layer. Okay. So this is nothing but deep learning network. One of the type of deep learning network often used in every projects. Okay. So then one more application of deep learning is handwriting digital recognition. Okay. So here also this is the example for example done by convolution neural network. Okay. It's also a project here. Here different feature maps. Feature maps means if this different patterns from the handwriting is given as the input to the convolution layer, and then pooling is done. After that convolution is done, then again sampling, like that repeated process is done in CNN, and you'll get the final output as that is all the layers are again now finally fully connected. Okay, so each convolution layers are we are taking the output, and finally the fully connected layer will be getting the output, and that we can check the result. Okay, classify result. These are the outputs. Okay, so the summary of CNN, it is composed with, as I already said, it is convolution layer, pooling layer, fully connected layer. Okay, so in each pooling, convolution is done, and final all the pooling layers are summed up within the under the fully connected layer, and you'll get the output using activation function. Okay, so this is about my presentation, and one small will be going now uh, to do some expressions in Google Colab. Okay, participants, anyone, do you have the idea of Google Colab? Thank you.
Dear participants, you can ask your queries. You can unmute your mic and please interact with our resource person.
Okay, I'll be handling Google Colab, ma'am, for a few minutes, and then I'll go for the questionnaire. Okay.
Okay, ma'am. Okay.
Okay. So participants, they can have the idea of programming in different languages. Okay, that is software languages, ML languages. Like for example, you can have you can solve you program, you can code the program in this Google Colab or Anaconda. You have to be install. You have to install this Jupyter notebook or this Anaconda notebook, and you have to install and then you can code. But here there is a simple user friendly programming software available in our Google itself, that is called a Google Colab. Okay, so for going to that, you can be just you can go through Google. I'll take the blank screen. You can browse Google. Okay, as Google Colab. Okay, so this is the way of taking Google Colab, and just you can type as Google Colab, and the first link it's coming as research.google.com. Welcome to collaboratory Google Research. Okay, you can click this first link. Okay, you can open like this. And now we'll be getting a pop-up window like this. Okay, so there is a pop-up window showing here, and here for new program, for going to new program, you can click on this new notebook. Okay, please note down, you can click on just to Google as Google Colab in Google, and actually for this you have you will have the Google account. Okay, for your own Google account you should have, then only you can uh, go into this, you can log in into this Google Colab. Okay, so now next step is just to click on the first link shown, and there will be a pop-up window, it's showing like this, and you can click on new notebook. Okay, new notebook. So just wait. Okay, I think your window is opening and my drive is full, I think. Okay. Wait, I will change my account. Sorry. Okay, so this is the window and this is the uh, cell. You can type the program. Okay, so participants, are you getting this window like this? Can you view my screen?
Yes, yes,
Ma'am?
yes, ma'am. Yes, ma'am.
Okay, okay, okay. So this is the window which we can program. Okay, so this is the Google Colab window, and you can edit this file. Okay, you can edit this. I actually the IPYNB is the extension file, it's a Python extension. Okay, so that there is no need to change the extension, and you can change only the file name. Okay, as your wish, you can give any name here. Just as FTP can give us. Okay, and you can simply you can program here. So some more mathematical for the mathematical for numericals, you can use this Google Colab easily. Okay, so the whatever program you are using here, the same you can use in Anaconda library also. Okay. So now you can let me execute a simple code in Python. Okay, just you can type print. Just whatever sentence you can give here, that is what just you can as an example. Okay. Okay, so for executing the code, you can either use this black button or otherwise shift plus enter. Okay, you can use shift plus enter. Okay, click here, click the cursor here. Okay, it will take a while, and it's running. The code is running, and you can see the statement displayed. Okay. Okay, so whatever code we are giving here, just it is printed, it's displayed. Okay, this is the basic thing of Python. Okay, just it's a free user library you can use for any code here. Okay. And here it will be adding a new cell automatically. It will be here your new cell is added, and you can um, execute so another program also. Okay. So for using NumPy program, first you have to import the NumPy library. Okay, so next one is you have to import NumPy library. Okay, for that you can use this code. So are you getting participants? Do anyone working on this? Okay, import import numpy as. So here after you can use this np. So it will be it will respond as numpy language. Okay. So this is the code to import NumPy library. Okay. So NumPy means it stands for numerical Python. Numerical Python. Okay, which we can use to manipulate the data, or you can process the data in the form of mathematical expressions. Okay, so many mathematical expressions you can create an array, or you can manipulate array. You can change the row into column into array. You can do any type of mathematical expressions using this Python language after importing. Okay, so then okay, so now it is imported. You click on this black button, otherwise shift plus enter. Okay, for executing that code. Okay, now you can create an array. Just for your understanding, I'm writing create a two-dimensional array. Okay. Sorry. np is numpy dot array. So for a two-dimensional array, you can use there is a nested list like this. So within the square bracket, wait, within the within inside the open bracket, you can use square bracket. Okay, double square bracket. Actually, double square bracket indicates two-dimensional array. Okay, double square bracket will be indicating two-dimensional array. Similar to that, if we need to create a three-dimensional array, you can use 3 dimensions, like that it goes on. Okay. So you can click this 2-dimensional. Okay. So inside, if you need a 3-dimensional array, you can give another one square bracket. Okay, similarly like this it goes on. Okay. So the meaning is that 2-dimensional, 3-dimensional, etc. It goes on. Okay. So for that you use a nested list with a double square bracket. Okay, double square bracket. So now enter data here. We can enter data to create a 2-dimensional array. Okay, so the specifications are coming over here. You can verify that. Just you can give your own data. Okay. So you need a double square bracket here for 2-dimensional. Okay, one more bracket you have to use here, and here also you have to use. So okay. Now we can execute the code and we will check it. So the variable name is A1. You can note that. And click on this button and the code is running. Okay, there is an error. Okay. Okay. So now the variable, the array of this A1, variable A1 is displayed here. Okay. Okay, I cannot view the Google Meet. What question is instead NP? No, instead of NP, we cannot give any other variable. That is actually, it is the imported form of NumPy. Okay, it is the standard form. You have to type only NP for NumPy. Okay, that is it. It is the inbuilt variable. It is the inbuilt variable. So you can't change this. Yeah, okay. Okay. Okay, now you have executed a array, and if time permits, we'll do some more numerical expressions, and we can if we can change this. Okay. So now we can before that we'll study learn some functions related to this array. So for typing, that is n-dimensional type, for typing for displaying the rows and number of columns, for getting the minimum value of the array, for getting the maximum value of the array, for getting the position or place of the array, like that different functions are there. Okay, one or two will not. Anyone, if you got the array, mention the chat box, please. Okay, ma'am. Okay. So if you know the matrix, that is how to change the array. How so? If you are giving a column in the left side, then it represents number of rows. It represents number of columns. If you know like that, you can itself do the codings. Okay, you can yourself do the programs. Okay, now I'll type of error. So there is, wait. So if you type like this, type of A1. So it represents n-dimensional array. Okay. You type like this and you execute. So it shows the type of the array. Okay. So you can, if you need, you can note down type of array. Okay. So this is the result, numpy.nt array. So the nt represents n-dimensional. Okay, nt represents n-dimensional array. So the array you are giving us, you are given us n-dimensional array. Okay, so the next function is, you can insert a new text cell. Okay, you can check the shape, a1 dot shape. Okay, it gives run and execute. Okay, so you are getting as 5 comma 3. Okay, the matrix with 5 rows and 5 3 columns. Okay, so first one is left side is the number of rows and right side is the number of columns. So 5 rows and 5 columns. Okay, so a1 dot shape, so it's you can note down a1 dot shape gives the number of rows and number of columns. Number of rows and columns. Okay. Okay, sorry, this is the code cell. Okay, so if we are entering the if you have to type the program, you can insert text cell. You can insert text cell. Otherwise, for coding purpose, you can use code cell. Okay, you can insert code cell, or you have the shortcut also. You can use that. Okay. Now you can find the minimum value of array. That is a1 dot min. A1 dot min of this a1, that is function of minimum of array. So execute, just execute and check. So it gives minimum value of array. Okay, please execute until, and if you have any doubt, you can clarify. Okay, you click on the execution button. What is the minimum value? You check the array. Check the array and you can see that 1 is the minimum value. Okay, 1 is the minimum value. Okay. If you want to check the array again, you can type A1 in the code cell. Okay, you can type A1 in the code cell and you'll be getting the array like this. Okay, here you can view that here 1 is the minimum. Okay, here 1 is the minimum value. Okay, next again you okay. Then A1 dot maximum. Just you can give us a maximum. Okay. Maximum value of array. So click on and check. So it will return the maximum value of array. Okay. So what is the maximum value here? 9. Okay, you are getting the maximum value. Okay, 9 is the maximum value in this array. Clear? So now next function is you can find the index value. You can say either as index value, or you can say the position of the position of either we can check the maximum value or you can check the minimum value. Okay. So for that the code used is a1 dot arg. Okay. min minimum. Now you check it. Use position of minimum value. Okay, now you can get the position of minimum value. So here you are getting the display as 0. Okay, you are getting the display as 0. So you can check this array. Actually, position of minimum value here is 1. Okay, it starts from the position 0. Okay, actually this is 0, not 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 0 to 13 elements are there. 0 to 13 elements are there. The starting 0th position is the value given as the element is 1. Okay, that is we get the answer. Next code is a1 dot arg maximum. Okay, you can give bus maximum. So it gives position of maximum value. Check out and find out the answer, please. Okay, you are getting the display as 13. Are you getting, participants? Okay. Okay, good. Okay, 13. So how you check out the value? This is maximum value is 9. Okay, maximum value used in this array is 9, and you can start from 0 to 13. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 13, the position is 9. Okay, so you are getting the answer as 9. Okay. Now some more functions are there. We'll go fast. So a1 dot n dime. Okay. What does n dime means? Can you tell? Just n dimensional array. Check it and get the answer, please. N dimensional. So we have created a 2-dimensional. The answer should be 2. Okay, we have created a 2-dimensional array. So 2-dimensional array, is it clear? Within the double square bracket, you can give any number of rows or columns. Okay, so that is two-dimensional array. If it is two double square inside, if it insert data inside two double square, means it is what mm, sorry, three-dimensional data. Like that it goes on. Okay. So we have created a two-dimensional data. Execute the code and check it. So the display shows us 2. Okay, the display shows us 2. That is, it is a two-dimensional data. Again, for your reference, I am giving gives the two-dimensional data. Okay. Then A1 dot D type. So D type is just a data type. Okay, D type is data type. Data type. So here the array given, we have actually A1 dot D type. Okay, A1 D type. The meaning is data type of of variable A1. Okay, that is the display showing here. A1 dot D type. That is data type of variable A1. Okay, so it will be coming as, let's check it. Data type is integer. Okay, 64-bit integer. Okay, so that is the answer. The data type is integer here. Next, insert a code cell and you can type the next command. A1 dot sum. A1 dot sum of within square bracket. The meaning is that adding. Okay, you can add all the elements in the array. So there's in an array. So these are some mathematical expressions. Utilized, and same thing what you are going to do in this Anaconda Jupyter notebook. Everything works in collab. Okay, so if you have memory space in your system, you can utilize this collab, and if you train more to code, you can do more programs. Okay, so we need more time to discuss complete programs or codings in this collab. Just I am giving some basic numerical expressions, as our FTP is related with the mathematical function of this machine learning. You are studying with some expressions, okay, which can be done using this ML language. Okay. So the answer here displayed as 73. You check it out manually, and you'll be getting the correct answer. Okay, so that is adding all elements. That is, you will get the summation of all elements in the array. Okay. So you have given us A dot D type. There is also one more similar. We can find the data of all elements. That is here the difference is that you are getting the data type of variable a1. Okay, you are getting the data type of variable a1, and you have another one expression, sorry, command. See, type of a1. Type of a1. Okay, so here if you check this, you'll get the type of the elements in the array. Here it shows the elements of, it shows the data type of variable a1. Here it shows the data type of the elements of a1. Okay, that is the difference. Elements of a1. Okay, or array. So it is a n-dimensional type of array. Numpy array. Okay, so this is the, it shows the data type of all elements in the array. Okay. So then you can also have the commands like you can get the column wise summation. This is a1 dot sum of function means adding all the elements in an array. Okay, you are having another one function which gives the summation of only column wise elements, and similarly only row wise elements. Okay, so I'll show the command. A1 dot sum of okay. It will give the column wise summation. Okay. Similarly, if we give 0 here, same command. A1 dot sum of axes equal to 1. If you give 1, you can get the row wise sum. Okay. 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 Still now, anybody has any doubt? Okay. One or two comments. We'll Sir, is it possible to continue for 5-10 minutes?
Okay, ma'am. Okay, no problem.
Okay. 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 One more or two comments. We'll check it and we'll leave. Okay. So second, this command is used for picking elements from array. Okay, picking elements from array, or it's we can say a slicing of arrays. Okay, slicing of array. Uh, Sorry, you can make the code A1 of. So for example, if you give us 2 means A1 of 2. So this is note down. Return the second row index. You can check the array also. Index means position. Index is nothing but position. Okay, you can also write this index position. Okay, A1 of 2. You are getting the display as print value as 644. Okay. So if you need, you can recheck the array. If you type as A1 and execute, run the program, you'll be getting the array. You can check it. Okay, so from this array, you can check this output A1 of 2. A1 of 2 means it returns the second row position. It is second row. Actually, this is zeroth row. Okay, don't confuse. First row is zeroth row. Zero, first and second. Okay, so the answer is displayed as 644. Okay. Similarly, you can execute any type of command. A1 of up to from 0 to 4. 0 to 4, if you give any type of numerical value, you'll get the row-wise data. Okay. Similarly, another one command is A1 within the bracket, enter colon 1. Okay, comma. What is this meaning? It gives the second column. Okay, just enter and execute. It's no time to type. Okay, it gives the second column. Okay. So for printing all the rows, do you know the command? For all the rows, just if you put colon, you can get the command. Okay, that is very much matrix method. When you study learning matrix, you will be come into know. Okay. You see, A1 of, just you put the column, okay, and execute. You see the same output. There will be no change. Okay, there will be no change. That is, it print all the rows. It print all the rows. Okay, that is the thing. Then two more comments are there. So if we give like this, the same thing. Left shows rows. Left column before the comma indicates rows. Okay, and the right side it indicates column. You can execute. Okay, the same thing. That is, all the rows and all the columns can be displayed. Then there is another one command called linspace function. Okay, linspace. So linspace means just you can get the values that is in between between this equidistant values can be noted. I will one more. So you can give a variable as another variable a2. Okay, a2 is linspace. Okay, a2 it's not assigning. We have to assign a1 and then we have to check it. Okay, sir. Almost it's time, and if possible, in another one chance, we can learn some more commands in this Google Colab. Okay. Thank you all participants.
Thank you,
Thank
madam.
you for your listening, and all the best for you all. Okay. Thank you, sir.
Thank you very much,
Close the
madam.
session.
Thank you very much, madam, for this wonderful session on artificial neural networks. I would like to invite our FDP coordinator, Dr. Anil AR, to propose the vote of thanks.
Dr. Menega Madam explained the basic concept of artificial neural networks and the different activation functions and the basic concept how it is implemented in Colab. I hope that everybody understand the basic concept and its implementation. Thank you, Madam, your excellent presentation, and thanks to the entire participants for your kind cooperation. Thank you, one and all. Thank you.
Thank you very much, sir. Thank you all the participants. Okay.
Dear participants, now we are going for a lunch break, and our third session will begin at sharp 2 p.m. on the topic Mathematical Models for Machine Learning by our resource person, Dr. Rajesh NK. We have posted the feedback link and also the recorded session of the previous day. Thank you all.
Thank you, ma'am. Shall I leave the session? Hello, hello, Anil sir.
Okay, ma'am. Okay, ma'am.
Anil sir. Let me leaving the session. Thank you
Oh,
all. Okay.
thank you. Thank you.
Okay.